Welcome to Veteach. In the previous sessions, we discussed about the variational methods, that is the concept of minimum potential energy as well as the ridge method, how to apply for the simple cases. Now, today we will discuss the weighted residual methods, that is we are having various weighted residual methods. So, what is the meaning of this weighted residual methods? Means generally this method will be applied for to get an approximate solution to linear as well as non-linear differential equations, and in this case we use this method in the finite element equation, which can be derived directly from the governor differential equation without any need of knowing the functional. That means here in the weighted residual method we are going to assuming some weightage of the respective function, the wave function, and we are going to solving the problem. And here we are having various methods, that is a point correlation method, subdomain correlation method, and least square method, and Galerkin method, that is PCM, SDCM, and LS method, and GM method. So in the weighted residual method, so what exactly the meaning of weighted residual method means? Generally we will apply this method preferably for non-structural problems, whereas for structural problems we will apply the ridge method, which already we discussed in the previous class. So in the weighted residual method, suppose if there is a function, we are going to giving the weight after the function, that is here the integration over the domain of the weighted residual will be is equal to 0. That means the product of the weight of the respective function and the residual will be integrated and it will be set to the 0. That is what we call weighted residual method, where the value of I will be 1, 2, 3, 4 like so on. That means there are several number of points. Over these points we are going to calculating the integration of the weighted function with respect to the residual, that will be set to the 0. So in this case, let us discuss first of all, that is a point correlation method. In the point correlation method, as we discussed that now weighted residual method is nothing but the weight of some function with respect to the residual of any variable, it will be set to 0 generally. Now in this case the point correlation method, so the residual is set to 0 when we take the n number of points. We can substitute any point in between the domain. For example, say in this case let us say x1, x2, x3, xn so on. In this method, that where we can substitute in the equation where x is equal to 1, 2, 3, 4, 5 like x1, x2, x3 the variables in the respective domain, and the residual is set to 0, not the integration, the residual will be set to 0, and we are going to calculate in the unknown variables. So suppose for example if you see this equation, that is the integration of delta x minus xi into the residual xi. Here when x is equal to xi, the weight of function will be 1, where the residual will set 0, whereas the weight function is equal to 0, and that means at any other point which is called as a PCM, that is a point correlation method. That means if the domain is let us say it is domain is 0 to L, I can substitute by taking any point in between this domain in the residual equation, and I need to solve for the unknowns. And similarly now the subdomain correlation method itself means that means here first of all a domain where the entire domain is divided into a number of elements, and for each element the integral of the residual over each subdomain is set to 0. That means in the case of the SDCM, that is subdomain correlation method, so simply we are going to integrating the residual with respect to the residual of the respective function will be 0, whereas in the case of point correlation method only the residual will be 0, whereas in this case the integration of the residual will be 0 over the domain. Suppose if there is a 0 to L domain, I can take the 0 to L by 2 in the subdomain case also. Like this I can apply this method in the subdomain, that is over the integral, that residual will be 0. This is the formula for the where The weight function will be, in this case, will be 1 because we are applying the subdomain. That is, in the case of subdomain, simply integration of residual will be 0. Now, in the least square method. So, what is the meaning of least square method? Means now we discussed that the weighted residual function is nothing but integration of the weight of the function, and respective residual will be set to 0. But in this case, in the least square method, the first of all we will calculate the energy, that is the potential energy, that is nothing but when you are having the differential equation, let us say the differential equation is R. Now in the least square means, first of all we have to square the residual with respect to the variable and we have to integrate. Then the functional will be expressed as a variable. This functional will be minimized as per similar to the potential energy theorem, minimum potential energy theorem, with respect to the any variable. That will be equated to 0. That means it is nothing but the integration of the square of the residual, first of all, which is called as a functional, it should be minimized. That is what we discussed here, the square of the residual should be minimized. And now the last method, Galerkin method. In this case, as we discussed now in the previous slide, generally the weighted residual method is nothing but the product of the weight of the function and the respective residual over the domain. It will be set to 0. But in this case, the weighted function is assumed as a polynomial function. That is the reason it is called as Galerkin method. In the Galerkin method, instead of weighing function, it will be assumed as a polynomial function, that is integration of y of x, where y is equal to a1 plus a2x plus a3x, it may be anything. That polynomial function will be taken and the respective residual is multiplied and integration will be set to the 0. So these are the four methods in the weighted residual method. Simply we can say that weighted residual method is nothing but the weight of the residual will be given and it will be set to the 0. But it varies based on the methods. In the point correlation method, the residual directly will be 0, where residual is nothing but the differential equation. We want to calculate the solution for this case. And similarly, as the subdomain correlation method, in this case where the integration of the residual will be set to 0. Whereas in this case, least square, the integration of square of the residual will be minimized, that is the functional I value will be minimized by partial derivative with respect to variable, that is dA by dA is equal to 0. And finally, the Galerkin method, instead of weighing function, we assume that the weighing function is a trial function, that is y of x into r residual dx, and it is set to the 0. So these are the various methods. The other end of the finite element methods we are going to using for both linear as well as non-linear differential equations. Basically it is used for the non-structural problems. So these are the four methods. Now we will discuss in the upcoming slides by taking the simple problems how to apply these methods in order to know the wave function, the trial function. Thank you.